Hey there, welcome back to the channel. Today, we're going to write a Java program to find the GCD of two numbers. If your goal is to become a proficient Java developer, understanding GCD, or greatest common divisor, is essential. Sometimes it's also called HCF, or highest common factor. Simply put, the GCD of two numbers is the largest number that divides both numbers without leaving a remainder. Let's start with an example. Imagine the two numbers entered by the user are 81 and 153. The highest number that divides both 81 and 153 perfectly is 9, because 9 times 9 equals 81. 9 times 17 equals 153. No number greater than 9 can divide both numbers evenly, so 9 is the GCD. Now, how do we implement this in Java? Let's break it down step by step. Step 1. Getting user input. First, we need to ask the user to provide two numbers. We'll use the scanner class for this. Here's the code. Import java.util.scanner, public class GCD example, public static void main string, args. Scanner sc equals new scanner system.in, system.out.print enter first number, int number 1 equals sc.nextInt, system.out.print enter second number, int number 2 equals sc.nextInt. Here, we import scanner, create an object sc, and use nextInt to take integer input from the user. The numbers are stored in number 1 and number 2. Step 2. Finding GCD using a for loop. The simplest approach is a for loop. The idea is: start from 1. Check every number up to the smaller of the two numbers. Find the largest number that divides both numbers evenly. Here's how the code looks. Int GCD equals 1, / initialize GCD to 1 for, int I equals 1, I less than equals number 1 and I less than equals number 2, I plus plus. If, number 1% I equals 0 and number 2% I equals 0. GCD equals I, / update GCD if I divides both numbers. System.out.println GCD is, plus GCD. Let's break this down. The loop starts from 1 and runs as long as I is less than or equal to both numbers. Inside the loop, we check if I divides both numbers evenly using the modulo operator %. If it does, we update GCD with this number. By the end of the loop, GCD contains the largest number that divides both numbers. If you run this code with 81 and 153, the output will be GCD is 9 perfect. That's exactly what we expected. Step 3. Optimized approach using a while loop. The for loop works, but it's not the most efficient. A faster way is to use a while loop based on the Euclidean algorithm. The idea is simple. Keep subtracting the smaller number from the larger number until both numbers become equal. The resulting number is the GCD. Here's the Java implementation. While number 1 equals number 2, if number 1 greater than number 2, number 1 equals number 1, number 2, else number 2 equals number 2, number 1. System.out.println GCD is plus number 1. Let's understand this with an example. Take 21 and 49. 49 greater than 21, so we subtract. 49 minus 21 equals 28. 28 greater than 21, subtract again. 28 minus 21 equals 7. Now 21 greater than 7, subtract. 21 minus 7 equals 14. 14 greater than 7, subtract. 14 minus 7 equals 7. Now both numbers are equal to 7, which is the GCD. This approach is faster because we reduce the numbers progressively rather than checking every possible divisor. Step 4. Running the program. When you run the optimized code and enter first number, 81, enter second number, 153. The output will be GCD is 9. Try another example. Enter first number, 21, enter second number, 49. Output GCD is 7. Key takeaways: the for loop method is simple and works for beginners. The while loop method is more efficient, especially for larger numbers. Understanding GCD is important because it's used in fractions, ratios, and algorithmic problems, and it often appears in coding interviews. That's it for this video. Now you know two ways to find the GCD in Java, using a for loop and using the Euclidean algorithm with a while loop. If you found this tutorial helpful, make sure to like the video so it reaches more people, and subscribe to the channel for more Java tutorials. In the next video, we'll learn how to find the LCM of two numbers in Java, which is another fundamental concept every developer should know. Thanks for watching, and I'll see you in the next one.